Rabaul, New Britain, February 8, 1945, 10:30 hours, and Lieutenant Commander Hiroshi Yamamoto of the Imperial Japanese Navy's 204th Fighter Squadron banks his Mitsubishi A6M0 into perfect position above a formation of what appear to be lumbering American F4U Corsairs climbing laboriously toward his altitude, their bent-wing silhouettes familiar targets that his pilots have been shooting down with regularities since Guadalcanal. Yamamoto, a veteran ace with 31 confirmed kills and absolute confidence in the Zero's superior maneuverability, watches these latest examples of crude American engineering with the practiced contempt that 2 years of aerial combat have taught him. Heavy, ungainly fighters that his nimble Zeros will dance around like hummingbirds attacking eagles. What Lieutenant Commander Yamamoto cannot possibly know, what no Japanese pilot could comprehend in their most terrifying nightmares, is that the F4U-4 Corsairs climbing below him are powered by 2,450 horsepower R2800 engines that can propel these clumsy fighters to 448 miles per hour in vertical dives, creating energy advantages that will render Japanese dogfighting tactics obsolete and turn every engagement into a high-speed execution where maneuverability means nothing and raw speed means everything. Within 10 minutes, Yamamoto's entire squadron will be scattered across the Pacific as blazing wreckage, victims of American fighters that attack like lightning bolts from heaven, diving faster than Japanese pilots can react, firing in fleeting seconds, then climbing away at speeds that make pursuit impossible and revenge unthinkable. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you.
The Japanese Naval Air Force's confidence in February 1945 stemmed from 3 years of aerial combat that had seemingly validated their tactical superiority and aircraft design philosophy over American aviation doctrine. Lieutenant Commander Yamamoto commanded pilots who represented the culmination of Japanese fighter development, flying aircraft that embodied the Bushido spirit through mechanical perfection designed for individual combat excellence. The Mitsubishi A6M0 had achieved legendary status as the most maneuverable fighter aircraft in the world, capable of outturning any Allied aircraft while maintaining the range and climbing ability that made Japanese pilots masters of Pacific airspace. Commander Takeshi Saito, leading the air group that included Yamamoto's squadron, possessed absolute faith in Japanese tactical doctrine that emphasized individual pilot skill and aircraft maneuverability over the crude power-based approaches favored by American aviation. Japanese fighter pilots trained in aerobatic maneuvers that pushed their aircraft to performance limits that American pilots seemed unwilling or unable to achieve, creating tactical advantages that had proven decisive in every major air battle since Pearl Harbor. Preparing and narrating this story took us a lot of time, so if you are enjoying it, like this video. It means a lot to us. Now, back to the story. The technical superiority of the Zero fighter was evident in its ability to outmaneuver any Allied aircraft in turning engagements, while maintaining fuel efficiency that allowed extended combat patrols over vast Pacific distances. Japanese aviation engineers had created an aircraft that could climb faster, turn tighter, and operate longer than any enemy fighter, establishing air superiority through superior design rather than brute force engineering that characterized American aircraft development. Captain Kenji Nakamura, Yamamoto's most experienced wingman, had achieved 18 confirmed victories, flying Zeros against American fighters, demonstrating the tactical advantages that superior maneuverability provided in aerial combat. Nakamura's success exemplified Japanese fighter doctrine that emphasized precise flying and tactical patience, waiting for optimal engagement opportunities where Zero advantages could be exploited against heavier, less maneuverable American aircraft. Flight Petty Officer Yoshiro Matsuda, the squadron's rising ace with 12 kills, represented the new generation of Japanese pilots who had learned aerial combat against increasingly capable American opponents while maintaining the tactical superiority that Zero performance provided. Matsuda's victories against F-6F Hellcats and P-38 Lightnings proved that Japanese fighter tactics remained effective against the latest American aircraft when properly executed by skilled pilots.
What Japanese intelligence services observing American aircraft development could not comprehend, could not measure from their understanding of fighter design priorities, was the revolutionary transformation that American engineers had achieved in power plant technology that created performance advantages transcending traditional aircraft design limitations. The F4U-4 Corsair represented not merely an improved fighter, but a fundamental breakthrough in aviation engineering that combined overwhelming power with aerodynamic efficiency to create capabilities that Japanese aircraft design philosophy could not match. The genius behind F4U-4 development was Chance Vought's chief engineer Rex Basel, who had solved the seemingly impossible challenge of installing a 2,450 horsepower Pratt & Whitney R2800 engine in an airframe that could withstand the structural stresses while maintaining controllability and combat effectiveness. The engineering solutions required for this power plant integration had pushed American aviation technology beyond anything attempted in fighter aircraft design, creating performance capabilities that exceeded every previous limitation of single-engine combat aircraft. The technical specifications of the F4U-4 Corsair represented engineering achievements that Japanese aviation experts would have considered impossible based on their understanding of aircraft design constraints. The fighter's maximum speed of 448 miles per hour in diving flight exceeded the terminal velocity limitations of Japanese aircraft, while maintaining structural integrity that allowed pilots to pull out of high-speed dives without aircraft failure. The engineering solutions required for this power plant integration had pushed American aviation technology beyond anything attempted in fighter aircraft design, creating performance capabilities that exceeded every previous limitation of single-engine combat aircraft. The Pratt & Whitney R2800 double WASP engine that powered each F4U-4 represented its own technological revolution, delivering more horsepower per pound than any previous aircraft engine while maintaining reliability under combat conditions. The 18-cylinder radial configuration incorporated technical innovations including fuel injection, turbo supercharging, and precision manufacturing that allowed sustained operation at power levels that would destroy Japanese engines. Each R2800 could produce 2,450 horsepower for combat operations while maintaining service life exceeding 500 hours. Production engineer Margaret Davis, overseeing F4U-4 manufacturing at Chance Vought's Stratford facility, had developed quality control systems that ensured each completed aircraft met performance specifications that Japanese industry could not achieve even in prototype development. The precision manufacturing required for high-performance fighter construction demanded tolerances and materials technology that exceeded Japanese capabilities, creating systematic advantages in aircraft reliability and combat effectiveness. The armament installation in each F4U-4 challenged Japanese assumptions about fighter weapons systems, as American engineers had integrated 6.50 caliber machine guns with sufficient ammunition capacity for sustained combat engagement. The concentrated firepower available to Corsair pilots could destroy enemy aircraft with short bursts while maintaining ammunition reserves for multiple engagements, creating tactical flexibility that Japanese pilots with limited cannon ammunition could not match.
The strategic innovation represented by F4U-4 operations extended beyond aircraft technology to include tactical doctrines that abandoned traditional dogfighting in favor of energy-based combat that exploited American power and speed advantages. Major Robert Anderson, developing fighter tactics for Marine Corps aviation, had created engagement procedures that maximized Corsair performance while negating Japanese maneuverability advantages through systematic use of altitude and speed differentials. The concept of energy fighting represented a fundamental departure from traditional air combat doctrine that emphasized turning ability and sustained maneuvering engagement.
American tactical development recognized that fighters with superior power could control engagement parameters by choosing when and how to fight, using speed and climb rate to initiate combat on favorable terms while avoiding prolonged maneuvering that favored lighter, more agile aircraft. Fighter pilot Captain Thomas Mitchell, commanding VMF 214, equipped with F4U-4 Corsairs, had perfected attack techniques that exploited the aircraft's diving speed to achieve tactical surprise while maintaining escape capability that prevented Japanese retaliation. Mitchell's pilots learned to attack from high altitude in high-speed dives that delivered devastating firepower in seconds before climbing away faster than Japanese fighters could follow, creating engagement patterns that Japanese pilots could not counter effectively. The training regimen for F4U-4 pilots emphasized altitude maintenance and speed conservation rather than the aerobatic maneuvering that characterized traditional fighter training. American pilots learned to use their aircraft's power advantages to maintain energy states that kept them above and faster than enemy fighters, creating tactical situations where Japanese maneuverability advantages became irrelevant because engagement occurred on American terms. Squadron tactics developed for F4U-4 operations included coordinated attacks that used multiple aircraft to maintain continuous pressure on Japanese formations, while individual pilots retained energy advantages through altitude and speed management. The systematic approach to energy fighting created tactical superiority that transcended individual aircraft performance through coordinated use of American technological advantages.
The mathematical reality of F4U-4 performance advantages over Japanese fighters represented systematic superiority that could not be overcome through pilot skill or tactical innovation when American aircraft were properly employed. The speed differential between Corsairs and Zeros in diving flight exceeded 100 miles per hour, creating engagement windows where Japanese pilots could not respond effectively to American attacks or prevent American escape from unfavorable tactical situations. Aerodynamic engineer Dr. Theodore von Karman, analyzing F4U-4 performance data, had identified diving speed capabilities that exceeded Japanese aircraft limitations by margins that made tactical parity impossible when American pilots exploited their performance advantages. The structural strength and power loading of the Corsair allowed sustained high-speed operations that would destroy Japanese aircraft through structural failure or control surface effectiveness loss. Test pilot Commander Frederick Trapnow, evaluating F4U-4 combat capabilities at Naval Air Test Center Patuxent River, had documented performance characteristics that exceeded every specification requirement while maintaining handling qualities that allowed average pilots to exploit the aircraft's advantages effectively. The combination of power, speed, and structural strength created capabilities that Japanese aircraft design could not match without fundamental redesign of their entire fighter program. The climb rate achieved by F4U-4s powered by R2800 engines exceeded Japanese fighter capabilities by margins that allowed American pilots to regain altitude advantages even after diving attacks, maintaining energy states that kept them superior to Japanese aircraft throughout extended combat engagement. The sustained power output that American engines could maintain gave Corsair pilots tactical options that Japanese pilots with less powerful aircraft could not duplicate. Combat analysis conducted by American intelligence officers indicated that F4U-4 performance advantages would be decisive in air-to-air combat, provided American pilots avoided turning engagements where Japanese maneuverability could negate American power advantages. The systematic exploitation of speed and altitude advantages could achieve air superiority through tactical doctrine that played to American aircraft strengths while avoiding Japanese aircraft advantages.
Japanese intelligence services, despite their early war success in evaluating American aircraft capabilities, suffered from fundamental blind spots when it came to understanding the revolutionary nature of F4U-4 performance and the tactical implications of American power advantages. The complexity of American engine development and the systematic approach to energy fighting tactics exceeded Japanese analytical frameworks based on traditional fighter combat and aircraft design priorities. Colonel Minoru Genda, responsible for Japanese fighter development strategy, had received reports describing American fighters with extraordinary power and speed capabilities, but these assessments were evaluated using Japanese design philosophy that prioritized maneuverability and fuel efficiency over raw performance. Japanese aviation experts, operating within resource constraints and material limitations, could not conceive of aircraft design approaches that sacrificed efficiency for overwhelming power advantages. The systematic failure to understand American technological development extended beyond individual aircraft to include misunderstanding of American tactical doctrine and pilot training methods. Japanese intelligence assumed that American pilots would continue employing traditional dogfighting tactics that favored Japanese aircraft design philosophy, failing to anticipate the energy fighting techniques that would negate Japanese maneuverability advantages. Major Saburo Sakai, Japan's most experienced fighter pilot, had encountered F4U Corsairs in combat and reported aircraft with impressive speed and firepower, but his tactical analysis emphasized traditional engagement approaches that assumed prolonged maneuvering combat where Japanese pilot skill and aircraft agility would prove decisive. The concept that American fighters might avoid turning combat entirely while maintaining tactical superiority was beyond Japanese tactical understanding. Intelligence analysis conducted by Japanese aviation experts consistently underestimated American engine development and aircraft performance capabilities, leading to tactical planning based on incorrect assumptions about enemy aircraft limitations. The systematic failure to understand American technological priorities resulted in defensive preparations that were inadequate for the capabilities American aircraft actually possessed. The increasing frequency of encounters with American F4U-4 Corsairs throughout late 1944 and early 1945 provided Japanese pilots with growing evidence that enemy aircraft capabilities were evolving beyond their previous understanding. The performance characteristics demonstrated by these new American fighters suggested technological development that exceeded Japanese estimates of Allied aviation progress. Flight reports from Japanese pilots described American fighters that could accelerate and climb at rates that seemed impossible for aircraft of their size and weight, while maintaining sustained performance that Japanese aircraft could not match during extended combat engagement. The systematic advantages in power and speed were becoming apparent to experienced Japanese pilots who had previously relied on maneuverability to achieve tactical success. Commander Saito, analyzing combat reports from his squadrons, began to recognize patterns in American fighter tactics that suggested coordinated approaches to aerial combat rather than the individual prowess that characterized Japanese fighter doctrine. American pilots appeared to be employing systematic tactics that exploited aircraft performance advantages while avoiding the turning combat where Japanese fighters retained superiority. The psychological impact of facing American fighters with apparently unlimited power and speed began affecting Japanese pilot confidence, as aviators who had dominated Pacific skies found themselves unable to catch fleeing American aircraft or prevent American attacks through traditional defensive maneuvering. The tactical certainty that had sustained Japanese aviation was being systematically eroded by encounters with enemy aircraft that operated beyond Japanese performance reach. Intelligence summaries reaching Japanese aviation headquarters described American fighter capabilities that exceeded previous assessments, while suggesting production numbers that indicated widespread deployment of advanced aircraft throughout American Pacific forces. The implications for Japanese air defense were becoming clear to commanders who realized that their tactical advantages were being systematically negated by American technological superiority.
The detailed analysis of F4U-4 Corsair performance characteristics revealed engineering achievements that exceeded Japanese aircraft development by margins that made competitive response through incremental improvements impossible.
The systematic advantages in power plant technology, structural design, and systems integration created performance capabilities that Japanese aviation could not match without fundamental revision of their entire fighter development program. The R2800 double WASP engine installation represented the most significant advancement in fighter power plant technology since the development of reliable aircraft engines, delivering horsepower levels that enabled performance characteristics previously considered impossible for single-engine fighters. The fuel consumption required for sustained combat operations at maximum power exceeded Japanese estimates of American petroleum availability, yet Corsair operations continued without apparent resource limitations. Structural analysis of captured F4U components revealed materials technology and manufacturing techniques that exceeded Japanese industrial capabilities, particularly in high-strength aluminum alloys and precision machining that allowed aircraft operation at stress levels that would destroy Japanese aircraft. The systematic advantages in material science created performance capabilities that Japanese aircraft could not achieve regardless of design excellence. The integration of advanced systems, including fuel injection, supercharging, and electrical equipment, demonstrated American technical sophistication that exceeded Japanese aviation technology while maintaining reliability under combat conditions. Japanese aircraft systems that required constant maintenance and careful operation were being compared to American systems that operated reliably under abuse that would disable Japanese equipment. Manufacturing quality analysis indicated American production techniques that achieved precision and consistency exceeding Japanese handcraft methods while maintaining production rates that suggested unlimited aircraft availability. The systematic advantages in industrial capability were creating numerical superiority that compounded the technical advantages American aircraft possessed. As February 1945 progressed, the evidence of American fighter superiority was accumulating beyond Japanese ability to dismiss through tactical explanations or pilot error. The systematic advantages in aircraft performance and tactical capability were creating conditions for aerial combat that Japanese training and doctrine had not prepared for effectively. The F4U-4 Corsairs that Japanese intelligence had failed to fully comprehend were preparing to demonstrate the full potential of American aviation technology applied to fighter combat. The combination of overwhelming power, systematic tactics, and industrial production was creating capabilities that would revolutionize air-to-air combat through performance advantages that Japanese aircraft could not counter. Lieutenant Commander Yamamoto, reviewing intelligence reports and pilot debriefings, understood that Japanese aviation was approaching a crisis that would test every assumption about fighter combat and aircraft design priorities. The stage was set for aerial engagements that would demonstrate the decisive nature of American technological superiority over Japanese aviation excellence. The blue-painted fighters that Japanese pilots had learned to recognize were about to reveal their true capabilities through combat demonstration that would prove speed and power could triumph over agility and experience when properly applied through systematic tactical doctrine. The angels of death were climbing toward their first test of revolutionary capabilities that would reshape air combat forever.
The performance calculations that defined F4U-4 capabilities revealed mathematical advantages that made traditional fighter combat equations obsolete when American pilots properly exploited their aircraft's revolutionary characteristics. Engineering analysis demonstrated that Corsair diving speeds created engagement windows where Japanese pilots could not respond effectively regardless of their experience or tactical skill. Aerodynamics specialist Dr. Ernst Heinkel, working with captured American technical data, calculated that F4U-4 diving performance exceeded Japanese fighter capabilities by margins that created tactical situations where time and distance factors favored American aircraft regardless of initial positioning or numerical odds. The systematic advantages in acceleration and maximum speed created engagement parameters where Japanese maneuverability became irrelevant.
Combat analysis indicated that F4U-4 pilots who maintained proper altitude and speed management could engage Japanese formations at will while retaining escape capabilities that prevented effective retaliation. The mathematical certainty of American tactical advantages when properly employed suggested that air combat outcomes would be determined by aircraft performance rather than pilot skill when engagement occurred under optimal conditions. The energy retention capabilities of F4U-4 aircraft meant that American pilots could sustain multiple attack runs against Japanese formations, while Japanese fighters lost energy through defensive maneuvering, creating cumulative advantages that grew throughout extended combat engagement. The systematic nature of American performance superiority created tactical situations where Japanese numerical advantages became meaningless. Flight test data indicated that F4U-4 climb rates and sustained speed capabilities allowed American pilots to control engagement initiation and termination regardless of Japanese tactical responses, creating combat conditions where American forces could achieve decisive advantages through systematic exploitation of performance characteristics rather than individual combat skills.
As the morning of February 8th progressed, both Japanese and American forces were making final preparations for aerial combat that would demonstrate the revolutionary impact of American aviation technology on traditional fighter tactics. The encounter that was developing would prove that technological superiority could overcome tactical experience when aircraft performance advantages were systematically exploited. Japanese pilots performed their traditional pre-flight rituals and aircraft inspections with confidence born from years of successful combat, while American Corsair pilots conducted systematic checks of their revolutionary aircraft with professional precision that reflected industrial warfare training. The contrast in approach would soon be reflected in combat results that validated American technological and tactical development. The weather conditions over Rabaul provided optimal visibility for aerial combat, while wind patterns favored neither side in the engagement that would soon demonstrate whether Japanese pilot excellence could overcome American technological advantages. The clear skies that Japanese pilots had dominated for years were about to witness combat that would revolutionize understanding of fighter aircraft capabilities. Lieutenant Commander Yamamoto, leading his formation toward what appeared to be routine interception of American bomber escorts, was approaching the moment when Japanese aviation would discover that the rules of aerial combat had been permanently changed by American engineering excellence applied to fighter design and tactical doctrine. The encounter that was minutes away would prove that the age of maneuvering combat was ending, replaced by speed-based tactics that favored industrial capacity over individual skill, marking the beginning of aviation's technological revolution that would determine air superiority through engineering excellence rather than pilot artistry.
Captain Thomas Mitchell rolled his F4U-4 Corsair into a near-vertical dive from 28,000 feet, watching his airspeed indicator climb past 400 miles per hour as the massive R-2800 engine pulled his fighter toward the unsuspecting Japanese zero formation below with the inevitability of gravity itself. The mathematical precision of energy fighting was about to be demonstrated with devastating clarity as Mitchell's squadron executed the high-speed attack doctrine that would render Japanese maneuverability advantages meaningless in the span of seconds. The Japanese Zero pilots below maintained their traditional defensive formation, confident in their aircraft's ability to outmaneuver the approaching American fighters through the turning combat that had proven successful throughout 3 years of Pacific warfare. Lieutenant Commander Yamamoto, leading his squadron in what he expected would be another routine interception, had positioned his aircraft for the climbing spiral that would bring his guns to bear on the American formation while exploiting his Zero's superior agility. What Yamamoto could not anticipate was that the F4U-4 Corsairs above him were not approaching for traditional dogfighting, but were instead initiating an energy-based attack that would exploit their 448-mile-per-hour diving capability to achieve tactical surprise and overwhelming firepower concentration in engagement windows measured in seconds rather than minutes. The revolution in fighter tactics was about to prove that speed trumped agility when properly applied through systematic doctrine.
Mitchell's diving attack achieved speeds that placed his Corsair beyond the reaction time of Japanese pilots trained for conventional fighter combat as the massive American fighter plunged through the zero formation like a thunderbolt, its 650 caliber machine guns delivering devastating firepower before climbing away at rates that made Japanese pursuit impossible. The psychological shock of facing fighters that attacked at speeds exceeding Japanese comprehension was as devastating as the physical destruction. The coordinated nature of the American attack became apparent as additional F4U-4s followed Mitchell's lead, each pilot executing diving attacks that exploited their aircraft's speed advantages while maintaining energy states that kept them superior to Japanese fighters throughout the engagement. The systematic application of American technological superiority was transforming air combat from individual contests of skill to industrial-scale destruction through overwhelming performance advantages. The tactical superiority demonstrated by F4U-4 operations against Japanese zero formations revealed the mathematical impossibility of traditional fighter combat when one side possessed systematic advantages in speed, power, and climbing ability. Flight Lieutenant Kenji Nakamura, attempting to engage the diving American fighters with conventional turning maneuvers, discovered that his Zero's legendary agility was meaningless when enemy aircraft could control engagement parameters through superior performance. The diving speed achieved by American Corsairs created engagement windows where Japanese pilots could not respond effectively, regardless of their experience or tactical skill. Nakamura's attempts to turn into attacking F4U-4s were thwarted by American aircraft that completed their attacks and climbed away before Japanese defensive maneuvers could bring guns to bear, creating tactical situations where Japanese aircraft became targets without achieving effective retaliation. Petty Officer Yoshiro Matsuda, flying as wingman in Yamamoto's formation, experienced the helplessness of facing enemies whose aircraft performance exceeded every tactical assumption underlying Japanese fighter doctrine. Matsuda Zero, designed for sustained maneuvering combat, could not match the acceleration and climb rate that allowed American fighters to maintain tactical initiative throughout the engagement, while Japanese pilots reacted to American attacks rather than initiating their own. The firepower concentration achieved by F4U-4 pilots during high-speed passes proved devastating to Japanese aircraft that had been designed with minimal armor protection to maximize maneuverability and range. The 6.50 caliber machine guns carried by each Corsair could destroy Zero fighters with short bursts delivered during fleeting engagement windows, while Japanese pilots required sustained fire from their lighter armament to achieve equivalent destruction. The systematic nature of American tactical doctrine became apparent as F4U-4 pilots coordinated their attacks to maintain continuous pressure on Japanese formations, while individual aircraft retained energy advantages through altitude and speed management. The organized approach to energy fighting created tactical superiority that transcended individual aircraft performance through coordinated exploitation of American technological advantages. The traditional defensive maneuvers that had protected Japanese fighters throughout early Pacific combat proved entirely inadequate against American aircraft that could attack at speeds exceeding 400 miles per hour while maintaining climbing capability that prevented effective pursuit. Commander Takeshi Saito, attempting to organize coordinated defensive responses, discovered that his squadron's tactical doctrine had no framework for countering enemies that could control engagement timing and positioning through superior performance. Japanese attempts to climb above attacking F4U-4s were frustrated by American aircraft that could maintain higher altitudes while possessing superior climbing capability, creating tactical situations where Japanese fighters remained below and slower than their enemies regardless of initial positioning. The fundamental performance advantages possessed by American aircraft made altitude parity impossible to achieve through tactical maneuvering. The turning combat that represented Japanese tactical superiority proved meaningless when American pilots refused to engage in sustained maneuvering and instead used their speed advantages to attack and disengage before Japanese agility could be brought to bear effectively. Flight Petty Officer Hiroshi Tanaka discovered that his Zero's ability to outturn any Allied fighter was irrelevant when enemy aircraft never entered turning combat. Japanese radio communications during the engagement revealed growing panic as pilots realized their tactical training was inadequate for facing enemies whose aircraft performance exceeded every assumption underlying their combat doctrine. The systematic failure of Japanese defensive responses created psychological effects that proved as devastating as the physical destruction of aircraft and personnel. The coordinated defensive maneuvers that Japanese squadrons had perfected through years of combat experience became liabilities when facing American fighters that could exploit Japanese formations' predictable responses through systematic application of speed and energy advantages. Traditional Japanese tactics that had achieved air superiority were being systematically countered by American technological superiority.
The performance differential between F4U-4 Corsairs and Japanese Zero fighters in high-speed combat represented systematic advantages that could not be overcome through pilot skill or tactical innovation when American aircraft were properly employed. The structural strength that allowed Corsairs to maintain controllability at 448 miles per hour exceeded Japanese aircraft design by margins that made high-speed engagement impossible for Zero pilots. Engine performance analysis revealed that R-2800 power plants delivered sustained horsepower that exceeded Japanese engine capabilities by factors that created acceleration and climbing advantages impossible to match through aerodynamic efficiency or weight reduction. The fundamental approach to aircraft design that prioritized power over agility was proving decisive when tactical doctrine exploited American advantages while negating Japanese strengths. Lieutenant Commander Yamamoto, attempting to pursue climbing F4U-4s with his Zero, discovered that his aircraft's engine could not maintain performance at altitudes where American fighters operated effectively. The supercharging and fuel injection systems that enabled R-2800 engines to maintain sea-level performance at high altitude exceeded Japanese engine technology by generations, creating performance gaps that tactical skill could not bridge. The ammunition capacity and firing duration available to F4U-4 pilots exceeded Japanese fighter capabilities by margins that allowed sustained combat effectiveness throughout extended engagements. American pilots could afford to fire longer bursts and engage multiple targets, while Japanese pilots with limited cannon ammunition had to achieve hits with minimal expenditure, creating tactical constraints that favored American aircraft in prolonged combat. Structural analysis of combat damage revealed that F4U-4 aircraft could absorb punishment that would destroy Japanese fighters while maintaining flight capability, creating survival advantages that allowed American pilots to continue fighting after receiving damage that would eliminate Japanese aircraft from combat. The systematic advantages in aircraft durability compounded the performance benefits of American design philosophy.
The psychological impact of flying aircraft with overwhelming performance advantages proved as significant as the tactical benefits, as American F4U-4 pilots developed confidence and aggressiveness that Japanese pilots flying inferior aircraft could not match. Captain Mitchell, leading his squadron through systematic destruction of Japanese opposition, experienced the mental transformation that occurred when pilots realized their aircraft could control every aspect of aerial engagement. The training differences between American and Japanese pilots became apparent as American aviators demonstrated systematic approaches to combat that exploited their aircraft advantages, while Japanese pilots relied on individual skill and traditional maneuvers that were being systematically countered by American technological superiority. The industrial approach to pilot training was proving as effective as the industrial approach to aircraft design. Flight experience reports from American pilots indicated that F4U-4 operations against Japanese fighters had become routine executions rather than contested battles, as the performance advantages of American aircraft made combat outcomes predictable when proper tactics were employed. The psychological effects of technological superiority were creating tactical dominance that exceeded the mathematical advantages of superior performance. Japanese pilot survivors of F4U-4 encounters reported experiences that challenged their understanding of aerial combat, as traditional tactical responses proved not merely ineffective but counterproductive when facing enemies whose aircraft operated beyond Japanese performance reach. The systematic failure of Japanese tactical doctrine was creating demoralization that affected combat effectiveness beyond the immediate disadvantages of inferior aircraft. The medical treatment of wounded pilots revealed the physical stress that high-speed combat placed on aircrews, as Japanese pilots attempting to counter F4U-4 attacks experienced G-forces and control pressures that exceeded their aircraft's design limitations, while American pilots operated within performance envelopes that their aircraft could sustain without difficulty. The systematic destruction of Japanese fighter squadrons by F4U-4 operations throughout February and March 1945 demonstrated that American technological superiority had achieved decisive advantages that could not be countered through tactical innovation or strategic redeployment. The mathematical certainty of American success when proper doctrine was employed made Japanese air defense increasingly hopeless regardless of pilot courage or tactical creativity. Intelligence analysis conducted by Japanese aviation headquarters revealed that American fighter production had achieved numerical superiority that compounded the technological advantages of individual aircraft performance, creating combined disadvantages that made effective resistance mathematically impossible. The industrial capacity that produced F4U-4s in unlimited numbers was proving as decisive as the performance advantages of individual aircraft. The operational tempo that American forces could maintain through superior logistics and aircraft availability exceeded Japanese capability to replace losses and maintain unit strength, creating cumulative advantages that grew throughout extended operations. Japanese squadrons reduced to skeleton strength by F4U-4 encounters could not be rebuilt quickly enough to maintain effective resistance against continued American operations. Fuel shortages that increasingly limited Japanese fighter operations while American aircraft operated without apparent resource constraints created additional disadvantages that compounded the performance gaps between aircraft types. The strategic bombing of Japanese petroleum facilities was achieving tactical effects through limiting the operational capability of surviving Japanese aircraft. The training pipeline that produced replacement Japanese pilots could not maintain quality standards when accelerated to replace combat losses, creating degradation in pilot capability that made encounters with superior American aircraft even more one-sided. The systematic destruction of experienced Japanese pilots was eliminating the tactical expertise that had compensated for aircraft performance disadvantages. By April 1945, the cumulative effects of F4U-4 operations against Japanese aviation had achieved air superiority that made Japanese fighter resistance ineffective regardless of tactical deployment or strategic positioning. The systematic advantages in aircraft performance, pilot training, and industrial support had created American capabilities that Japanese forces could neither match nor counter through conventional responses. The speed revolution demonstrated by F4U-4 combat operations had proven that energy fighting could achieve tactical dominance over traditional dogfighting when aircraft performance advantages were properly exploited through systematic doctrine. The fundamental assumptions underlying fighter combat had been permanently altered by American technological superiority applied through coordinated tactical development. Japanese attempts to develop countermeasures against F4U-4 operations proved futile, as American aircraft performance exceeded Japanese capability to respond through aircraft modification or tactical innovation. The systematic nature of American advantages made competitive response impossible without complete redesign of Japanese aircraft and tactical doctrine, requiring resources and time that were not available. The psychological impact on Japanese military leadership of facing American air superiority that could not be challenged through traditional means forced recognition that technological competition had become more important than tactical excellence in determining combat outcomes.
The industrial capacity that created F4U-4 superiority represented systematic American advantages that Japanese traditional approaches could not overcome. The strategic bombing campaigns enabled by American air superiority were achieving objectives that Japanese military resistance could not prevent, as F4U-4 escort fighters made American bomber operations virtually immune to Japanese interception, while maintaining tactical flexibility that allowed engagement of any remaining Japanese opposition on favorable terms. The remaining encounters between Japanese fighters and F4U-4 Corsairs throughout the final months of Pacific warfare demonstrated the complete tactical superiority that American technological advantages had achieved when properly employed through energy fighting doctrine. Japanese pilots, reduced to desperate defensive measures, could not achieve effective engagement against American aircraft that controlled every aspect of aerial combat. The mathematical precision of American tactical superiority became apparent as F4U-4 pilots achieved kill ratios exceeding 10-to-1 against remaining Japanese opposition while suffering minimal losses to enemy action. The systematic advantages in aircraft performance, armament, and tactical doctrine had created combat effectiveness that exceeded anything previously achieved in fighter operations. Lieutenant Commander Yamamoto, one of the few Japanese aces to survive multiple encounters with F4U-4 squadrons, reported that American fighter capabilities had rendered Japanese tactical doctrine obsolete while creating engagement conditions where Japanese pilot skill became irrelevant to combat outcomes. The revolution in fighter combat had eliminated individual excellence as a determining factor in aerial warfare. The final Japanese attempts to achieve tactical success against F4U-4 operations required desperate measures, including ramming attacks that reflected recognition that conventional combat could not achieve effective results against superior American aircraft. The systematic failure of traditional fighter tactics had forced Japanese aviation into kamikaze operations that represented abandonment of aircraft versus aircraft combat. The technological superiority demonstrated by American F4U-4 operations had proven that industrial capacity could create military advantages that traditional approaches could not counter, establishing precedents for technological warfare that would influence military development for decades. The speed revolution had permanently altered the nature of air combat through systematic application of engineering excellence to tactical problems.
The F4U-4 Corsairs' demonstration of decisive speed advantages over traditional fighter design established principles of aircraft development that would dominate military aviation throughout the jet edge. The systematic exploitation of power and speed over agility and maneuverability proved that technological superiority could achieve tactical dominance through proper application of engineering advantages. The tactical doctrine developed for F4U-4 operations became the foundation for energy fighting techniques that would characterize fighter combat throughout subsequent conflicts, as pilots learned to exploit aircraft performance advantages through systematic approaches that negated enemy strengths while maximizing friendly capabilities. The revolution in fighter tactics had permanent effects on military aviation doctrine. The industrial lessons learned from F4U-4 production and deployment demonstrated that manufacturing quality and systematic engineering could create military advantages exceeding anything achieved through individual craftsmanship or traditional approaches. The systematic application of American industrial capacity to fighter development had established new standards for military aircraft effectiveness. The psychological impact of F4U-4 superiority on both American and enemy pilots established confidence patterns that would influence military aviation for years, as aircrew learned that technological advantages could determine combat outcomes more reliably than individual skill or tactical innovation. The mental effects of superior equipment proved as important as the physical performance advantages. The strategic implications of F4U-4 success validated American approaches to technological development and industrial production that would characterize military procurement throughout the remainder of the 20th century. The systematic advantages achieved through engineering excellence and manufacturing precision had proven more decisive than traditional military approaches to achieving air superiority.
The final analysis of F4U-4 combat effectiveness against Japanese aviation revealed that the 448-mile-per-hour diving capability and associated performance advantages had achieved complete tactical superiority through systematic application of American technological development to fighter combat. The speed revolution had proven that properly applied engineering could overcome any traditional advantages in pilot training or tactical doctrine. The mathematical certainty of F4U-4 success, when proper energy fighting tactics were employed, had eliminated uncertainty from fighter combat while creating tactical situations where American victory was determined by aircraft performance rather than pilot skill. The systematic nature of technological superiority had made individual excellence irrelevant to combat outcomes. Japanese military analysis of F4U-4 encounters acknowledged that American fighter development had achieved systematic advantages that could not be countered through traditional approaches to aircraft design or pilot training. The recognition that technological competition had become more important than tactical excellence represented fundamental shifts in military thinking that would influence future development. The industrial implications of F4U-4 success established American approaches to military production and technological development as dominant methodologies that would characterize defense procurement throughout subsequent decades. The systematic advantages achieved through engineering excellence had proven more decisive than any traditional military approaches to achieving tactical superiority. Lieutenant Commander Yamamoto, reflecting on his encounters with F4U-4 Corsairs from his hospital bed, understood that Japanese aviation had witnessed a technological revolution that permanently altered the nature of fighter combat. The Blue Angels of Death had fulfilled their promise through speed that Japanese agility could not counter, proving that in modern warfare, engineering excellence would determine tactical outcomes more reliably than individual skill or traditional approaches to military aviation. The 448-mile-per-hour that German generals had dismissed as irrelevant to fighter combat had proven decisive in achieving American air superiority, demonstrating that technological superiority could achieve strategic objectives through systematic application of industrial capacity to military problems. The speed revolution was complete, and its effects would reshape military aviation forever. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.